Hello, Year 11 Mathematics Advanced students. Today we're continuing on with functions and we're doing finding a linear equation. So there is a formula you can use if you know the gradient and the coordinates of a point on a line. So the point gradient equation of a straight line is the linear function with equation y minus y1 equals m bracket x minus x1, which has gradient m and the point x1, y1 lies on the line. So let's have a look at some examples. We want to find the equation of the line with the gradient minus 5 and y-intercept of 3. So for this one, we can use our normal gradient intercept equation of a straight line, which is y equals mx plus c, where we have our gradient as our m and our y-intercept as our c. So our y-intercept is 3 and our gradient is negative 5. So our equation for this line will be y equals our gradient of negative 5x plus our y-intercept of 3. Now, for our next example, 1b, we want to find the equation of the line with gradient of 3 and x-intercept of negative 2. Oh, what are we going to do here? So we have an x-intercept of negative 2. So what we're going to do is we are going to use our point gradient equation of a straight line. So we're going to use y minus y1 equals m bracket x minus x1. Now you might be thinking, but I've only got a gradient and an x-intercept. But let's have a think about what the x-intercept is. The x-intercept is really the point negative 2, 0, right? Because an x-intercept crosses through the x-axis at negative 2. So it has a y value of 0. So we are going to substitute into our equation over here our gradient and our point minus 2, 0. So when we sub these in, we'll have y minus our y1, where our y1 is this 0 point, equals our m of 3 bracket x minus our x value, or our x1, of negative 2. So then this negative 2, when we have a negative times a negative, it turns into a positive. So that means now we have y minus 0, which is just y, equals, now we need to multiply this 3 into both terms in our bracket. So it will be 3 times x, which is 3x, and then 3 times plus 2, so it will be plus 6. So that means our equation of the straight line with a gradient of 3 and an x-intercept of minus 2 is y equals 3x plus 6. Moving on to example 1c, we want to find the equation of the line passing through 3 and 3, 5, the point 3, 5, and the point 5, 10. Now we have 2 points here, and that's all. We don't have a gradient, but we have 2 points. So what we're going to do is we need to find the gradient. So over to the side, or actually underneath, we're going to find our gradient. So looking back at last lesson, we found out that we can find our gradient using the formula m equals y2 minus y1 over x2 minus x1, where we sub in our points into this formula. So if we look at our points, what we have is 3, 5, which we're going to call x1, y1, and we have 5, 10, so it's going to be x2, y2. So now we're going to sub these points into our formula. So it will be our y2 is 10 minus our y1 of 5 over our x2 of 5 minus our x1 of 3. So 10 minus 5 is 5 over 5 minus 3 is 2. So that means our gradient is going to be 5 over 2. And we're going to leave it like that. Leave it as a fraction. So now we know a gradient and we know 2 points. So for us to use our formula y minus y1 equals m bracket x minus x1, we have our gradient, but we need to work out what point we are going to use for y1 and x1. Well, over here we stated that y1 and x1 was the 0.35. So let's substitute that and our gradient into our formula. So we'll have, I'm just going to do it underneath here, y minus our y1 of 5 equals our gradient, which is 5 over 2 times x minus our x1 of 3. So now that we have done that, what I'm going to do is I want to get rid of this fraction of 2 first. So I'm going to multiply both sides by 2 to remove the denominator of the fraction. So that leaves me with 2y minus 10 equals 5 bracket x minus 3. And then I'm going to multiply my 5 by both terms in my bracket. So I have 2y minus 10 equals 5x minus 15. And then because I don't have something in y equals form, I'm going to write it in general form, which general form is ax plus by plus c. So I'm going to move everything to the right-hand side of my equation, meaning I'm going to subtract 2y from both sides and plus 10 to both sides of my equation so that my 5x is positive. So my equation will now be 5x minus 2y minus 5 equals 0. And that is the equation of the line that passes through the points 3, 5 and 5, 10. Now we're going to move on to applications of linear functions. So we can use what we know about linear functions and apply these to business models and other real life problems. So our example here today says a solar panel company has fixed overhead costs of $3,000 per day and earns $150 for each solar cell sold. Okay, so let's highlight some key information. So it has fixed overhead costs of $3,000 per day and earns $150 for each cell sold. What we want to do in 2A is write the amount that the company earns on selling X solar cells per day. Okay, so we want to write the amount earned selling X solar cells each day. So what we are going to do is our equation is going to be A equals, because we're trying to find the amount. So the company earns $150 per cell. So that means that it earns $150 for X cells, right? So what we're going to do is we want to find the daily amount earned which we are going to call A, because we're trying to find A dollars. And then we're going to work out the value of the solar cells sold. So value of solar cells sold, which will be our $150 times X minus the overhead costs. So we have overhead costs each day. So each day it costs $3,000. And that is the amount that the company earns on selling X solar cells each day. So for every cell sold, they earn $150, so X times $150, but we have to subtract the overhead costs that they have to pay for using the company. So in 2B, we want to find the amount the company earned on a day when it sells 54 solar cells. So that means we're going to let our X equal 54. So we're going to sub this into our equation that we have just created. So we have A equals 150 times our X of 54 minus our $3,000, where our 54 was our X. So when we put this into our calculator, we get 150 times 54 minus 3,000. So we get an answer of $5,100 per day. So we write, therefore, the company earns $5,100 when it sells 54 cells. Okay? So pretty simple stuff. You're just substituting into the equation you have created. Now see if the company earns $2,850 on another day, how many cells did it sell? So what we know is we know A. So we are aware of what A is. So we know that it's 2,850. So we're going to substitute this into the equation. So we're going to have 2,850 equals our 150x minus 3,000. So then what we're going to do is we're going to plus 3,000 to both sides. So when we do that, we get 5,850 equals 150x. And then we're going to divide both sides by 150. And I have run out of room, so I'm just going to draw a little arrow to show where I'm going to. So when I divide both sides by 150, I get my answer for x. And when I go 5,850 divided by 150, I get 39. So therefore, the company sold 39 cells on that day. Okay. Now what we're going to do is work out for 2D what is the break-even point for the company. So a break-even point is where the income and the costs of the production are equal. So that means we're trying to find when A equals 0. So what we need to do is that we let A equal 0 and then we solve the equation. So we'll have 0 equals 150x minus 3,000. So then we plus our 3,000 to both sides. So we get 3,000 equals 150x. And then we're trying to find out what x is. So we divide both sides by 150. And so when we divide both sides by 150, we get x equals 20. So therefore, the break-even point is where the company sells 20 solar cells. So this just means that this solar company has to sell 20 solar cells each day at least to make back what their overhead costs are. So in order to make a profit. Okay. So if you were following the Maths in Focus Year 11 textbooks, if you are in advanced and following the advanced textbooks, you would now do exercise 306. And if you are in extension 1 and following that textbook, you do exercise 406. Have an absolute